Hello everyone, welcome to eMath Edge. My name is David Akwashki and I'm here to help you master mathematics and give you the edge you need to succeed in your exams. Here at eMath Edge, I'll practically be solving mathematics past questions for senior school certificate examinations for Nigerian students and possibly students across the Africa, where I will be breaking down the whole process into simple, easy to understand steps. I actually understand that preparing for mathematics exams can really be hectic, but believe me, understanding how to approach these questions, most especially the essay part, will ease you a whole lot of stress. And that is what this platform is designed to do for you. Each video tutorial is designed to boost your confidence and make math exams feel less like a mystery, but more like a basic thing you can conquer. So having said that, let's get started.
So here we are presented with question number 3, which is a WAEC question for 2015. Question 6b, which carries a total mark of 6. So the question says, find the value of theta that satisfies the equation. What is the equation? The equation is 3 tan squared theta minus 1, which is equal to 0. 3 tan squared theta minus 1, which is equal to 0, such that 0 degrees is less than or equal to theta, which is less than or equal to 360 degrees. Just like I've said in our initial video, that whenever you have a condition like this, 0 degrees less than or equal to theta, which is less than or equal to 360 degrees, what this condition is equally stating is that the value or the set of values you are supposed to obtain for theta must be in between 0 degrees and 360 degrees. So if you have anything more or anything less, that means something is wrong somewhere, okay? So let's begin. Let's write out solution. And let's bring down the question, which is 3 tan squared theta minus 1, which is equal to 0. So what we should be looking out for in solving this problem is to make tan theta the subject of the formula, such that whatever value we obtain for tan theta, we can go ahead and check the trigonometry table to find or to get the corresponding angles in degree. All right. So let's try to make tan theta the subject of the formula. So the first thing to do is to take this negative 1, which is the constant number in this equation, to the right hand side. So we are going to have 3 tan squared theta to be equal to 1. When negative sign is crossing the equal sign, it turns positive, and whenever a positive number is crossing the equal sign, it turns negative. Okay, so with this, we are going to divide both sides by the value 3. Remember, we are trying to make tan theta subject of the formula here, so we use all the mathematical principles to simplify the equation as much as possible. So the best thing to do for this is to divide through by the value by the number 3, such that we will be left with, let's have it to be 3 tan squared theta divided by 3 equal to 1 divided by 3, such that 3 will go with 3 and we will be left with tan squared theta to be equal to 1 over 3, right? Remember, the goal is to make tan theta the subject and not tan squared theta. So what we are going to do further is to find the roots or the square roots of both sides. Find the square roots of both sides. And the essence of finding the square root of both sides is for us to do away with the square. This tan squared theta is for us to do away with the square. So For us to do away with the square, we have to find the square root of both sides such that we are going to have the next equation to be the root of tan² to be equal to plus or minus the root of 1 all over 3. So, introducing root to the right hand side, we are going to have it to be both positive and negative. So, the root of tan² will cancel the square. So, we will be left with tan² to be equal to plus or minus the root of 1 all over 3, right? So, this is equally the same thing as the root of 1 all over 3, which is the same thing as the root of 1 all over the root of 3, okay? And the root of 1 is 1 all over the root of 3, okay? Or, mind you, we have plus and minus here, so it's going to be, let's say tan² is this, let's see, and tan² is going to be now negative the root of 1 all over 3, which is equal to negative root 1 all over root 3, such that it's going to give us negative root 1. Sorry, root 1 is the same thing as 1, is going to give us negative 1 all over root 3, right? So that's to say we have two different values, positive 1 all over root 3 and negative 1 all over root 3. What we are going to look at next is to obtain the corresponding angles in degrees for tan² such that tan² is equal to 1 all over root 3 and when tan² is equal to negative 1 all over 3, okay? When tan² is 1 all over 3, we are going to obtain the corresponding angles in degrees, and also when tan² is negative 1 all over root 3. So let's go further to check our trigonometry table. What are those corresponding angles? So looking at our trigonometry table, you check for the rule of tan. Where is tan² equal to 1 all over 3? At this point, we have tan² to be 1 all over 3. And if you check the corresponding angles in degrees, we have 30 degrees, right? So let's check further. Where do we have 1 all over root 3 again? At 210. At 210 degrees, we have tan² to be 1 all over 3. So that's to say the corresponding angles for tan² to be equal to 1 all over root 3 is 30 degrees and also 210 degrees. So let's put it down. Now for tan² equal to 1 all over root 3, this implies that we are going to have theta to be equal to 30 degrees and also 210 degrees from our trigonometry table, right? So we do the same thing for tan² equal to negative 1 all over root 3, right? So let's check the trigonometry table to obtain the value such that tan² is negative 1 all over root 3. Tan², where is tan² negative 1 all over 3? Let's check. Negative 1 all over 3 is at 150 degrees, as you can see, and also at 330 degrees, right? 330 degrees. So now let's go back. We have at 150 degrees and 330 degrees. Tan theta is -1 all over root 3. So for tan theta equal to -1 all over root 3, this implies that theta is equal to 150 degrees and also 330 degrees, right? So this implies that, or we can say, therefore, theta, the value for theta, or the set of values of theta is 30 degrees, comma, 150 degrees, 210 degrees, and 330 degrees. So these are the sets of values for when theta, or when tan theta is equal to 1 over root 3 and -1 all over root 3. And mind you, initially a condition was given that this set of values which we are to obtain for theta must be between 0 and 360 degrees, as you can see from the question. This is the condition. The set of values for theta must be between 0 degrees and 360 degrees. So if you observe what we obtain, or the set of values we obtain for tan theta is between 0 degrees and also 360 degrees. So these are the sets of values for theta which we were asked to obtain. So if you want to check, you can use the previous method we used in the other video to check if your values are correct.
That will be all for this video. Stay tuned and engaged for the next one. Also, remember that the goal of this platform is to solve as many past questions as possible just to help you overcome maths exams tension. So if you have any challenging question from this topic you would like me to solve, kindly drop them in the comment section or reach out to me via email or DM and I will be glad to assist. Thanks for watching and have a great day.